we did the summary session. You can find it on YouTube if you missed it.
Okay, thank you.
Yeah. So how many of you have seen the activity questions and practice assignments?
Madam, we solved so that other sessions they covered actually activity session and the practice questions. So maybe we can focus on the if the people are having any doubts that you can clarify, and we can go for previous any questions. So maybe you can work out.
Yeah, sure, sure.
Thank you.
So I will pick the specific doubt, and it can be from concept or it can be from question. So I will pick all the doubt. That is what I want to know. You are facing problem with which areas? I have one portion inverse. So I will discuss how to calculate inverse and range and domain. So anything other than that? Anything other than that?
No, for me, no, madam. So maybe the lectures, if the people covered lectures, maybe it will be there is no issue. So anybody having not covered means maybe they have doubt actually. They will have doubt.
Okay, so that's a problem. So, okay, I will then discuss some problem for my own.
Yeah.
Okay, so
Okay.
maybe, yeah, it will help you. So let
Thank
us first discuss inverse. Okay, so
Ma'am,
yes, yes, Manish. Okay, so let us start. Okay, so if you know, I mean, probably you all know that a function f, this is a function. So when can we call this function as invertible? When the function is injective and onto, right? That means
bijective function.
yeah, and onto. That means bijective function, right? So these two terms together called bijective function, bijection. Okay. So in that case, we will say the function is invertible, right? And now if a function f inverse exists for a function x,
Madam, you not shared the screen.
you cannot see the screen.
Yes, yes.
Yeah, ma'am. Oh, wait. Now can you see?
Yes, ma'am.
Okay. Now it is visible, right?
Yes, ma'am.
Yes, yes, ma'am.
So, uh, what are you talking about? Yeah. So if for a function f, if inverse exists, then we can denote it with f inverse, right? And in that case, the domain of f is basically equals to range of f inverse, and a range of f is basically equals to domain of f inverse. Okay. So if you have a given function, then you need not to if you ask to calculate the range and domain of the inverse function, then you need not to calculate the inverse, then the range and domain. It's enough if you can compute the range and domain for the given function, then domain of the given function will be equals to range of the inverse, and range of the given function will be equals to domain of the inverse. Okay. Is it clear? Is it clear?
Yes, until clear.
Okay. And we know because the function is invertible, then the domain is equals to codomain, right? That is what these two conditions are satisfying. So we can just simply calculate the range and domain for a function. Okay. And to find range of a function, if suppose we want to find the range of a function of f, so we will see in which point f can be defined, right? For example, if f of x equals to x square, then we can see that for any real number, we can define this function, right? There is no disturbance for any real number, right? This is the example. But suppose we have f of x equals to root over x. Okay, then we cannot take anything which is less than 0, right? Because then in the codomain portion, we will get something complex, right? With iota. So which this will not be real function in that case. And here we are only considering the real functions, right? So in that case, our domain will be x greater than 0. Strictly, sorry, x greater equals to 0, right? Now, if you just put the value in the function, then we will get f of x will be again greater equals to 0, right? So then in that case, the range and domain both are equals to close 0, open infinity. And here, the domain is clearly R, but the range is, what will be the range? Is the only the positive portion of the real line, right? That means 0 to infinity, right?
Yes, ma'am.
Because
Yes, ma'am.
if you take any negative number, we are squaring, right? So after squaring, we will get something positive, right? Okay. So for example, another example, suppose we have f of x equals to some x by x minus 1. Okay. So from this type of function, you can find that at some point the function may face some problem. So which is what is the point in that case? At which point we
Ma'am,
can
x
face
cannot
some
be 1.
Yes, right. That means if x is 1, then we will get something like 1 by 0, right? So this is something not defined. So x is not equals to 1. Hence the domain will be, what will be the domain? And there is no problem with any of the problem in our, any of the point in our real line except 1, right? That means the domain will be, what will be the domain?
All real number minus 1.
Minus 1.
Yes. This is the domain. And what will be the range? What will be the range? What will be the range? You can simply analyze the function. If we if you tends x towards infinity, then what will happen?
Infinity.
Okay, so we can, if you are confused with the function, then we can apply some little tricks. So we can break this function as x minus 1 plus 1 by x minus 1. Okay, then in the next line, it will be 1 by x minus 1. Okay, now what will be the case if extending to infinity?
1.
1, right? So if you are facing some doubt or dilemma regarding the function, then you can just cleverly do 1 or 2 steps and you can express it in a simplified way. Okay. So when x will be tending to minus infinity, 1 from the positive side, right? 1 from the positive side. And when x will be tending to minus infinity, then the function will be tending to
1.
say tending to 1 from the negative side, right? Right?
Yes, ma'am.
Are you getting my point? Okay. Because if we tend x tending to positive side, this portion will be tending to 0 from positive side, right? Right? And if
Yes,
x tending to
ma'am.
minus infinity, then this portion will be tending to 0 from the negative side. Okay. So if we add 1, then it will be tending to 1 from positive and negative side accordingly. Okay. Okay, that means we have this as our domain 1, right? And what if x tending to 1, then what will be the behavior of fx?
Infinity.
Undefined.
No, we are not putting 1 directly. We are taking x tending to 1. You just have to calculate a limit here.
0.
So it's simple. If x tending to 1, then x minus 1 will be tending to 0, right? And then 1
0.
by x minus 1 will be tending to infinity, right? So if we add 1 with infinity, then it will be again tending to infinity, right? Clear?
Yes, ma'am.
1 from the positive side, okay? That means we get 1 to infinity, right? We can find 1 from the positive side and infinity, right? So 1 to infinity we get. Now what if x tending to 1 from the negative side? You can do this 2-step, then you can easily calculate. If x tending to 1 from the negative side, then what will happen? What will be x minus 1 then? Tending to 0 from the negative side, right? Right?
Yes, it's 0.
Yeah. Then 1 over x minus 1 will be tending to minus infinity, right? This is tending to 0 from the negative side. That means this is something negative, right? Right? So if we take 1 by x minus 1, it will be tending to minus infinity. So we get minus infinity to 1. So this is our range and this is our domain too. Is it clear?
Simply we can
Is it
say
clear?
that simply we can say, so 1 is not valid. So x, if take 1, so it is not valid. So I'm enclosing this 1 is a bracket. That's it. Open
Yes,
bracket
yes.
1 and here open bracket 1. That's it.
Yes, yes. We are just excluding the point 1. So the
That's
steps
it.
are, yeah, so the easy steps are like first you have to calculate the domain. Okay. Then if the function is continuous, then you have to calculate the behavior of the function in the end point of the domain, right? So for in this example, our domain was minus infinity to 1, union 1 to infinity, right? This was our domain. So we check the behavior of the function in these 4 points. I mean, 1 from positive side and from negative side, both the side, right? Then we came to the conclusion that the range is also minus infinity to 1, union 1 to infinity. Okay, so these are 2 steps. So just you have to follow these steps and then you can calculate the domain and range for any function. Okay, so do you have any doubt regarding this process?
No, ma'am.
Okay, so it's clear for everyone, right?
Ma'am,
Yeah.
ma'am, can you solve the same domain and range for another function? I was facing
Yes.
difficult. Yeah, f of x equal to square root of x square minus 4.
F of x equals to
Square root of
square root
x square minus 4.
minus. So this is the given function.
Yeah,
Okay.
I'm actually confusing with the domain and the range, ma'am, because in the previous problem also you concluded that domain and range almost same. I'm having little
Yeah,
confusion.
in this case, domain and range are same, but in general, they are not same. Na? In this particular case, we found them to be same.
Okay.
Yeah.
Ma'am, range would be from 0 to infinity, right?
Why?
Yes, yes. No,
Why?
he's saying about the below question.
Okay, in this question.
Yes,
Yeah.
ma'am. X square minus 4, root over x
Yeah,
square
yeah,
minus 4.
yeah.
Range would be from
Okay.
0 to minus 4, and domain
0
would be
to
from minus infinity to 2, minus 2, and 2 to infinity.
okay.
Yeah.
0 to 4 is the domain. What did you say? Can you repeat?
No.
What is the domain?
Zero
Mi-
to infinity.
0
You are
to
saying domain from minus infinity to
-2
union
and 2 to infinity.
open bracket. Yeah, that is what he's saying.
Okay. And what is the range?
0 to
0.
infinity.
0 to.
Ma'am, -2 and 2 will be included in the domain.
Okay. I mean close, right?
Yes, ma'am.
Okay. So let's see. So this is under root, right? That means if we like want to define the function, then we need this portion to be positive, right? That means x square minus 4 to be greater equals to 0. So it will imply x square greater equals to 4, right? That means x greater equals to 2 or x less equals to -2, right? So the domain will be same, like minus infinity to -2 union 2 to infinity. Okay, so that is clearly correct, right? And the range will be clearly 0 to infinity, right? Right?
And
If
that is,
you,
yeah, ma'am,
yes.
how that is 0 to infinity? I don't
Okay.
understand.
Okay. So
Okay, the domain
similarly,
I got it. Yes, ma'am.
Yeah. So see, if we see it graphically, so this is suppose on -2, this is suppose our 2, and this is toward infinity, this is toward minus. So this is our domain, right? This is our domain. Okay. So we will check in this boundary point, the behavior of the function. Okay. So what will happen if x tending to infinity? Then f of x will be tending to infinity, right?
Yes, ma'am.
Yes, ma'am.
Okay. Yeah.
Seems like-
And
yeah.
if x tending to minus infinity, then f of x tending to infinity
Plus
again, right?
infinity.
Yes. If x tending to 2, then f of x will be tending to
0.
Infinity. Infinity?
uh,
0, 0.
no. You just have to follow simple steps. Huh? We are taking x tending to 2. That means x squared will be tending to 4, right? So what will be the case for x squared plus -4? It will be tending to 0, right? These are the step. You have to follow this step every time. So f of x will be tending to 0. And what if x tending to -2? Same, right?
Then
F of
also
x
0.
again will be tending to 0.
0.
So we get it's, yeah. So we get it's varying from 0 to infinity, right? So our range will be 0 to infinity. Is it now clear? Is it clear now?
Oh, my.
Madam, that
Why,
range,
like, in
range,
which
can you please explain again? So
A
range?
domain part I
yeah,
got it, ma'am, but
yeah,
range.
yes, domain is okay, but range maybe.
Range domain is very clear, ma'am. Range 0 to infinity. Can you actually it is a parabola, upward facing parabola, right, ma'am? If you draw the graph for this function.
No,
No,
this
with
is
x
not a
square minus.
parabola. This is not a parabola. This portion is the equation of parabola, but we're taking
Yeah.
root here.
No,
So this is
I'm not
not a
considering
parabola.
the root, ma'am. Just x square minus 4 means it will be like upward facing parabola.
Yes, yes.
Yes, for that the domain, okay. But the range part 0 to infinity, why not the negative part?
Because what I said, you just have to follow this step every time. I mean, you have once you have the domain, you will just check the behavior of the function in the boundary points. Okay. So what are the boundary points here? It's tending to minus infinity, tending to minus
Minus
2,
plus
tending to 2, and
2 and
infinity. Right?
infinity, yes.
Yeah. So when x tending to infinity, then we found that f of x is tending to infinity, right? Same for minus infinity, right? This is fine, right?
Yes, yes.
Okay. That means we will get the end behavior will be something like that. Like both will be in the positive direction, right?
Yes, ma'am.
Yes. So clearly there is nothing nothing negative we cannot conclude from here. But from the next line we can conclude when x is tending to 2, we can find that f of x tending to 0, right? Similarly, when x is tending to minus 2, again we found that if f of x is tending to 0, right? So these two conclusions are okay, right?
You are saying this as graphically or equating as like x square
In
minus
both
4
way you
equal.
can say. I mean, in both way you can say. I mean, when x is tending to 2, I mean, when x is tending to 2 from this direction, okay,
Okay.
then our graph is tending to 0. Okay, that
Okay.
means
Okay.
something like that. Okay,
Okay.
and when x is tending to infinity in this direction, then our graph is tending to infinity in something like that. Okay,
Yes. Yes. Okay, ma'am.
similarly, when x is tending to 2 from this side, this arrow, then the graph is tending to 0, something like that.
Okay.
Right?
Okay.
Again, when x is tending to minus infinity, the graph is tending to infinity, like that.
Infinity. Yes. Yes.
Now we can find the range, right? Which is clearly this is not crossing the point 0, right? So the range will be from 0 to infinity. Is it now
Infinity.
clear?
Yes, ma'am. Yes. Zero is included. Zero is included. Yes.
Yeah,
Okay, ma'am. Thank you.
because 2 and minus 2 is included, right? So we can put the 2 and minus 2 directly in the function, then we will get 0, right?
Yes,
If you
ma'am. Yes.
put 2 and minus 2 here, you will get 0, right? So 0 is included here. Now is it clear?
Yes, ma'am. Perfect. Thank you, ma'am.
Madam, this for exponential,
Okay. So any
madam, for exponential, for negative portion won't come, right? So only 0 to
hmm.
infinity only, right? So that kind of also we can assume the range, right?
Yeah, if you have some pure exponential function, then the range for exponential function is from 0 to infinity. Yes.
Yeah. Okay. In
0
this,
means open 0.
yeah,
Open
in this
0.
anything, maybe if it's not required, maybe we can minus that numbers.
Yeah. Like if you have something like, for example, f of x equals to some 3 power x plus 20. Okay. Then we know that this function is clearly defined on the real line, right? Because we
Yes.
don't have any problem here. So what will be the domain then? We know that the domain for this function is, that means 3 power x is greater than 0, right?
Yes.
So if we just add 20, then we will get simply it will be greater than 20, right? So
Yes.
in that case, our domain will be this. Sorry, our range will be this.
Okay.
Okay.
So anyway, it's a default we can
Yeah.
take from 0 to infinity. So that
Yeah. For exponential function, the range is the domain is real number and the range is 0 to infinity. This is by default. Yeah.
okay. Okay. Thank you.
And for the logarithmic function it will be just opposite, right? Because you know that logarithmic function is just inverse function of exponential function, right? So the domain of exponential function is range of logarithmic function, and range of logarithmic function is domain of exponential function, right?
Logarithmic
Ma'am,
function maybe this week,
Ma'am,
maybe next week, I think.
Yeah, next week we will discuss about logarithmic function. Yeah, someone was asking something.
ma'am,
ma'am is can I there can we say that reversible functions are same as inverse functions? Like both are same meaning.
Yeah, reversible means, yeah, it can be reversed, like it reverse exists for the function, that means inverse exists for the function. So reversible function and invertible function are basically same. I mean, they're just different terms.
Okay, ma'am. Yeah, that's yeah. That.
Yeah. Okay, so yeah, any other doubt?
ma'am,
I mean, yeah.
here that x cannot be equal to 1, right?
In which question?
Exponential function,
X, Y?
because it will be a constant then.
Okay, I mean for x, but there is no problem if x is equals to 1, no?
But ma'am, we all the time we make two cases, right? Greater than 0, less than 1, and then greater than 1. We never take 1.
Okay, this is specifically, I mean, if you suppose if you take 1, then there is no problem, right? I mean, for 1,
Yes,
the
ma'am. There
function is
is
also
no
defined.
problem, but it will
Hmm.
no longer be exponential, right? It will become a constant as soon as we take 1.
See, if it is like constantly 1, x equals to 1 constantly, then this is a constant function. But when we are like varying x and all over the real line, then it is not a constant, na? Because it will give 3 at just one point. When x equals to 1, we will find the value 3.
Yes,
Okay,
ma'am.
but not for all the points, right?
Yes, ma'am.
Yeah.
Okay, ma'am.
Yeah.
Madam,
So x can be anything. I mean, there is no problem with x. But if you have something like a power x, then a is not equals to 1, because if a is equals to 1, we will get a power 1 power x, which will be equals to 1. So this is a constant function for any x. Okay. But if you take 3 power x or a power x for any a not equals to 1, then we will not get any constant function. We will get the value a for just 1 point. Okay, so this is not a constant function. But instead of a, if you took 1, then it will be a constant function. Okay, but instead of x, we can take 1. There is no problem, because we are varying x. In a, we are taking something fixed. So this cannot be 1. But in x, this can be any number from the real line system. Okay, is it clear?
Yes, ma'am. Yes, ma'am. So A we should not take 1.
Yeah, because there
Okay.
is no meaning, na? If you take a equals to 1, it's still defined, but it's a constant function, right? So this is not exponential function, right? We will get just a straight line. I mean, y equals to 1 straight line, right?
Yes, ma'am. Yes, ma'am.
Ma'am,
So we cannot take, yeah.
ma'am, an exponential function cannot be a constant function like in this case.
No,
Why?
no. Exponential functions are not constant function, because exponential functions have the property, they are monotone function. I mean, if either they are monotonically increasing, no, or they are monotonically decreasing. Okay, so if we have something like a is greater than 1, then we will get something like this. The graph will be like that, right? Monotonically increasing. And if a is less than 1 and greater than 0, then the graph will be something like that. That means monotonically decreasing. But if you take a equals to 1, then we will get the graph like that. So it will not satisfy the property of exponential functions even, right? So this is not an exponential function. So
Okay, ma'am. Ma'am,
we
we can also
cannot take
the
a
converse
equals to
of this
1.
statement, right? Like a
What can you?
function, ma'am, we can also say the converse of this statement, like that function which is monotonically strictly increasing or decreasing, that is a exponential function. Otherwise, it's not a exponential
No,
function,
no, no,
right?
no, 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 no. See, we cannot see. I mean, if a function is exponential, exponential function has the property that it will be monotonically increasing. Otherwise, it will be monotonically decreasing. But if a function is monotonically increasing or decreasing, then we cannot say that it is an exponential function. So, for example, you can take this straight line. This is monotonically decreasing, right? But this is not an exponential function. Or this cubic type of graph, this is also monotonically increasing, right? But this is not a exponential function. Okay, is it clear? Is it clear?
Yes, ma'am. Yes, ma'am.
I mean, exponential function will be either monotonically increasing or monotonically decreasing. Okay, but converse is not true. I mean, a function can be monotonically a function which is not an exponential function it can be monotonically increasing or decreasing. Okay.
Yes, ma'am. Got it. Thank you, ma'am.
Yeah. Yeah.
Ma'am,
Okay. Yes.
ma'am, I have a doubt in activity question, ma'am.
Yeah.
Five.
Which one?
So, activity 5.8, fourth question.
5.8.
Yeah, composite functions. Fourth one.
This one.
Yes, ma'am.
Okay. So what is the problem?
Ma'am,
How,
even I'm having the same doubt. Yeah.
how do we find the domain, ma'am? Like they have given the domain for FOG and it's quite complicated. I mean, I found it difficult to solve this.
Okay. So wait, what happened? Shit.
I'm not sure they have solved in open session because some of the open session recordings are still not provided publicly. So I could not see that also. Otherwise, I would have referred that.
Today it was
Yeah,
solved.
there are some recording problem. Maybe I didn't solve it. Maybe I'm not sure. I couldn't remember. But okay, let's see what is the problem. I mean, if the domain of the composite function, so we have given domain of the composite function and we have the function f. Okay, so what can we comment about the domain of a composite function? What is domain of a composite function? So domain of f compose G, we know that this is equals to domain of G such that range of G is subset of domain of F, right? This we know, right?
Yes, ma'am.
So domain of f compose G is given, and we know that domain of f compose G is exactly equals to domain of G such that range of G is subset of domain of F. If any case range of G is not a subset of domain of F, in that case we have to restrict the domain of G in such a way such that range of G becomes the subset of domain of F, right? That we already know, right?
Yes.
Okay. So first we calculate what is the domain of F. We have F equals to x1 over x square, right? So what is the domain of X then? Anyone? We are having problem with
R
one.
minus 0.
Yeah, only 1 point, which is 0, right? So the domain of F will include all the point except the point 0, right? So this is domain of F. Okay. So we have to take one function, exactly one function from that, such that the domain of this function will be this, such that the range of the function will be this. Okay. So suppose if we take the first function, what is the domain for the function? What will be the domain for the first option? It's
minus 2 to infinity.
minus 2 to infinity. Minus 2 close or open?
Close.
Okay, so this is the domain, right? And what is the range?
0 to
What is the range?
infinity.
0 to infinity.
0 to infinity.
0 close or open?
Close.
Close.
Yes, perfect. So you can see that this is basically this function is the domain of the function is this and range of the function is this. So if we need this range to be subset of, we need this range to be subset of this function, right? That means we need to exclude the point 0, right? If we want to exclude the point 0 from the range of this function, then we have to exclude a point from the domain too. So which point do we need to exclude? What is the pre-image of 0?
0.
What is the pre-image of 0? We need to exclude 0 from the range, right? Because we need R to be subset of domain of F, right? So we
Yes.
need to exclude the point 0, right? So what is the pre-image of 0 for this function?
Minus 2.
Minus 2.
Okay, so we can exclude -2 from here, right? So then the domain will be, if we exclude -2, then the domain will be -2 to infinity, right? So clearly this is satisfying this condition. So this is a possible correct answer, right? So the
Ma'am,
first
could you
option.
repeat the last two steps once again, the excluding and
Yeah, from pre-image, even I did not get that.
Okay. So we have the domain and range for the first function, right? Now we need this condition. That means the range of this function, that means our G, should be subset of domain of F, right? And what is domain of F? This is R minus 0, right?
Zero, yes.
So
Yes.
domain of F doesn't include the point 0, but range of G include the point 0 here, right?
Yes.
We have a closed interval. So we need to exclude the point 0 from the range of G. Then it will be a subset of domain of F, right?
Yes.
Okay. Now, if you want to exclude the point 0 from the range of the function, in order to do this thing, we have to exclude some point from the domain of the function, right? I mean, domain of the function G, right? Then we need to find that point for which the function is giving the value 0, right? Right?
Yes, ma'am.
That means the pre-image of the point 0, right? Is it clear?
Instead of this and 1 by x square, just substitute this one gx, so that on finding the domain, it's more easy than this.
Yeah, this is
Actually, I
another way.
was following that method, but it
Yes,
was
that
going
is
more
easy.
complicated. That is going more complicated.
Yeah,
No
because
complicated.
With all the
sometimes
options, ma'am.
you may have some difficult function, right? So every time calculating the composite function, then calculating domain, it may be something complicated. So it's better if you just learn to analyze the function like that. Okay. So in that way you can also do, because in this case the function is simple, but not every time the function will be simple, right? So you have the condition, this condition. You just have to satisfy this condition. We need that the range of G should be subset of domain of F. And we know 0 is not in the domain of F. So, and 0 is in the range of the function G, right? So we have to just exclude the point from the range of G, right? So if we want to exclude one point from the range, then we need to exclude the pre-image of the point from the domain, right? So if there is no pre-image for the function in the domain, then we will not get that particular point in the range, right? Really, we are restricting the domain.
Becomes open bracket -2 to infinity. Okay.
Ma'am, your voice is breaking.
So in order to is it clear now?
No, ma'am. The
Is
second
it
option.
same for everyone or is it? Yes.
Yes, intermediate is breaking your voice.
Okay, so in my area we are facing some network issue actually today. So there may be some problem, but if you're not understanding my voice, then you can ask me. I will repeat. Okay. So in that case, we can exclude the point -2 from the domain of the function G, right? Then the domain of the composite function will be open -2 to infinity, right?
Yes.
So this is satisfying the condition. Then the first option is clearly correct, right?
Correct. Yes.
Yeah. So what about the second option? We can do similar type of observation for all the function, right? So what will be the second option?
0.
Here? What is the domain here? What is the domain here?
-2 to infinity excluding 0.
Yeah, -2.
Oh yeah, -2 to infinity, including 0, right? So what will be the range? Similar process. You just have to check for the in the boundary points. That means we can break it like that: -2 to 0. union 0 to infinity, right? Now we will check from the negative side of 0, from the positive side of 0, and towards infinity and towards -2. Okay, so what will be the range? If we take extending to infinity, then what will you get? Here the power is less, right? Here the power is greater, right? Here we have the power of x is half. Here we have 1, right? So we can say it will be tending to 0. Right? Is it clear?
No, ma'am.
Okay. So here the power of x is half, and here the power of x is 1. That means, okay, if you can say it in that way, you can take x common, then this function will be 1 plus 2 over x under root x power half, right? And we have 5x. So we can cancel them out, then we will get x power half here. Then if you take extending to infinity, then what will we get? We will get this function will be tending to 0, right? Right? And if extending to 0, then this function will be tending to infinity, right? Are you getting my point? Are you getting my point?
Yes, ma'am. Ma'am, may I know which function is getting to the infinity?
This one, the second function.
No, the range is getting to 0, right, ma'am? How could it go to infinity?
Okay, I mean, when x is tending to 0, 0 on the positive side.
Yes, ma'am.
Then this portion, I mean, root over 1 plus 2 by x by 5 x power half. This we have, right? So this will be tending to infinity in that case, right? Because this term will be tending to positive infinity, and this term will be this whole term will be tending to positive infinity, right? Is it clear? We will get infinity into infinity, no? I mean, you can write it as root over 1 plus 2 by x into 1 over 5 into x power half. So if we take x tending to 0, then this portion will be infinity, right? X is tending to 0,
Yes,
that
ma'am.
means 2 over x will be tending to infinity. So 1 plus 2 over x will be tending to infinity. Again, this portion will be tending to infinity. So multiplication will be tending to infinity, right? Is it clear now?
Yes, ma'am.
Okay. So when x is tending to 0 from the positive side, the function is tending to infinity. F is tending to infinity. And if x is tending to 0 from the negative side, then what will happen? This will be tending to minus infinity, right?
Yes, ma'am.
So if we x tending to 0 from the negative side, then f of x will be tending to minus infinity.
Ma'am, could you draw the graph of the function like a rough graph? Rough, no need.
Yeah,
Just
sure. We can check the NVA, then we can draw the graph. And what if x tending to -2? Then this function will be tending to 0, right? Tending to 0, right? So let's see the domain. -2 to 0 and 0 to infinity. This is the domain, right? So when x is tending to infinity, graph is tending to 0. That means something like that, right? Is it clear? When x is tending to when x is tending to 0 from the positive side, then the graph is tending to infinity. That means something like that here, right? In the above direction. Similarly, when this is tending to 0 from the negative side, the graph will be tending to minus infinity. That means something like that, right? Near 0. And when x is tending to -2, then the graph will be tending to 0, like that. Clear? Is it clear?
Yes, ma'am, somewhat.
Yeah. So we can roughly we can find the range will cover like minus infinity to infinity, right? And the point 0, I mean the whole real line basically, right? It will attain the point 0, right? At the point -2. So the range will be whole real line, right? Is it clear?
Yes, ma'am.
Yeah, because we can find all possible numbers. Okay, minus infinity to infinity in the range. Okay, so the range will be whole real line. And if we want, suppose the range is as a subset of domain of f, that means we have to restrict it in what is domain of f? It was, what was domain of f? Sorry, what was
R
domain
minus
of
0, ma'am. R minus 0, ma'am.
yeah. Yeah. So domain of f was r minus 0, right? So we need to exclude the point 0. That means it will be, and what was the range of the function? This was for -2 to 0 union 0 to infinity, right?
That is the domain, ma'am.
Right? Yeah, this is the domain. And range is real line, right? Now, if we
Yeah,
want the
minus
range as a subset of this, then we need to exclude the point 0 from here, right? That means we have to exclude the pre-image of 0 from the domain in similar way, right? Now, what
Yes,
is
ma'am.
the image of 0? This is -2, right? So if we exclude the point 0 from the domain, then the from the range, then the domain will be -2 to 0 union 0 to infinity, right?
Yes, ma'am.
Because -2 is the pre-image of the point 0. So this is clearly not equal to -2 to infinity, right? Hence this option is it clear now?
Yes, ma'am, it's
I mean
clear.
the whole process we will do.
Yeah, understood.
Yeah. So for the last two option, we have to do some same similar type of things. Okay, then you can solve it.
Ma'am,
So
a small doubt is there
it
in the C
okay?
option. Could you solve the C option?
Okay. You have to tell me about like that shape. Okay. So what is the for the option 3? Now our function is this. Okay. So what is the range here? I'm sorry. What is the domain here? What is the domain here? Tell me. What is the domain?
The domain will be all R minus all R excluding -2.
Hello. Is my screen visible now? Am I audible?
Screen is not visible, ma'am. We can't see the screen, ma'am.
Please wait. Actually, in my area, I'm facing some network issue, so it may be a problem for today. So please just wait for 2 minutes. Yeah, can you see the screen now?
Still loading.
Can you see the screen now?
Yes, ma'am.
Yeah. So is the page visible? I mean the fourth problem. Or is it lagging? I mean, maybe it's lagging, right? Can you
Yes,
see
ma'am.
the fourth problem?
Yes, ma'am. Now we can see, but it's lagging.
Yeah, it's lagging. I can also see it's lagging. This is because of some network issue, maybe. Okay, anyways, I'm audible now, right? My voice is not breaking right now, right?
Right.
Is it breaking?
No, ma'am.
Okay. So we were discussing about the third option, right? So, yeah, what is the range of the third option? Sorry, what is the domain of the third option?
-2 to infinity, open brackets or -2.
Yes, correct. And what is the range? What is the range? Similarly, we have to check for the boundary points. So what will be the range? If we take extending to infinity, then we will get something towards 0, right? What if extending to infinity?
0, ma'am.
This will be
Then
0.
0.
So f will be tending to 0 and 0 open, right? And if x is tending to -2, then
1/4.
for
0
this
to
one,
infinity.
-2 from the positive side. That means this
The
will be
domain is
tending to,
-2 open close bracket, right?
yeah, no, open bracket. At the point -2, this function is not defined, right? Then we will get 3 by 0. So this is not defined, right?
It will
So
tend
what
to
if,
3.
no,
So x plus
3 by
2
root over
greater
x
than
plus 2, no?
Yes,
If
ma'am.
x is equals to -2, then we will get 3 by root over of 0, right? That means 3 by 0. So this is not defined, na? So you have to exclude the point -2 from the domain.
okay.
Clear? So if x
Clear.
is tending to -2, then what will be the case? Like what will the behavior of the function gx? X
Infinity.
plus 2 will be,
Option 4 is correct.
this will be f will be tending to infinity, right?
The
Right?
range is 0 to infinity.
Yeah. So the range is 0 to infinity, right? That means this is also a possible function, right?
Ma'am, I'm having a doubt in
Yes.
like while calculating at
Yes.
the endpoints, ma'am. Could you do it for the last when it tends to 2? Once again, could you do it? How it is tending to infinity? I'm not able to understand.
Okay. So when it tends to 2, wait. If we take for this function, right? So if we take x tends to -2, then x plus 2 will be tending to 0, right? 0 from the positive side, right?
Yes, ma'am.
So what will be then root over x plus 2? This will be tending to 0. right?
Yes,
So
ma'am.
1 over x plus 2 will be tending to infinity.
Okay, yeah. Yes, ma'am, I understood. Yeah,
If you
I get it.
multiply it with 3, it will be again tending to infinity,
Infinity.
right?
Yes, ma'am. Yes, got it, ma'am.
So just you have to just in 2 or 3 steps you can calculate this type of thing. Okay, these are not difficult, so you just have to follow the same type of step every time. Okay, if you just following same type of step, then you will face no difficulty whatever, I think. Okay, so is the problem clear? You can check these 2 options are correct. So
Yes,
similarly,
ma'am. Clear, ma'am. Clear, ma'am.
yeah, okay, so it's clear for everyone, right?
Yes, ma'am.
Okay. So any other problem in your activity questions?
Ma'am, I have a question. Generally, a function has been given, and they are asking us to find domain and range. So, can we have a generalized steps? Like, what is the steps to be followed so that we can quickly find out what is the first thing we should take in?
Yeah,
Take.
these are the generalized step. I mean, you have to first calculate the domain. So domain is basically the set of all points where the function can be defined. So if you have the domain once, then just have to check behavior of the function at the end point. Okay.
Okay.
Then we can calculate range. I am following this step. Now, this 2 to 3 step. You have to follow these 3 steps for to calculate the range and domain. Okay. First calculate the domain, then just check the behavior of the function in the boundary points, then
Mhm.
conclude about the range. If you have something in closed, I mean, if the closed interval type of thing, then you have to check at this point the function is attending the point or not. So in that way you can conclude whether the interval will be closed or open. Okay, you just need to check the behavior of the function in the boundary points.
Okay.
Clear? Yeah.
Okay.
So these are 3 steps. You need to follow these 3 steps every time. Okay. So this 3 step is basically enough if you want to find the domain and range of a function. Okay.
Okay.
Ma'am, 5.4 second question once. Could you go there?
Yeah, sure.
No, that I
5.4
just want
question
to,
number.
Ma'am.
I just want to know that I joined around only 8:15. Is the summary session over already?
Yes. For week 5, summary
Ah,
session is already over. It was in last Tuesday probably. So you can find the recorded lecture in the YouTube too. I mean the recorded live session.
okay. Thank you.
Okay. So summary session is already over. So this is the open session.
Ma'am, why, ma'am? Some of the open sessions are still not um, published in the calendar, ma'am. They are asking for a request access. Why is that so, ma'am? Like previous days, October 30th,
Uh,
November 1st, open sessions.
it should not be the case. I mean, there by TAs or instructors.
TS.
Okay. In that case, maybe you have to we have to give you permission access for this. That was yeah. I will talk about it
Because
instructor.
in that Excel sheet also it is not updated, ma'am.
Yes. So you are facing problem with last 2 week or what?
Yes, ma'am. Like that. Similarly, for the previous week also I faced. So that is why I've tried to attend the live session today.
Okay. I will tell Bishal to update the access. Then you can join. Okay.
Okay, ma'am. Okay. Thank you, ma'am.
Yeah. Ah. So 5.4 question number.
2, ma'am. I'm having doubt in asymptote, horizontal asymptote. Yeah.
Okay.
Could you solve the
So
asymptote part only?
okay, sure. So mm, first, if you want to solve it mathematically, then you just need to check the limit when extending to infinity or extending to minus infinity. Okay. So if x is tending to minus infinity, then clearly you can check that if x will be tending to minus 32, right? So this is the horizontal asymptote. And if you want to check it graphically, then also we can do it like
Ma'am, how you have once again could you repeat the words which you have told just now? Minus
yeah.
infinity. Once again, could you tell that part?
So basically, if you want to check horizontal asymptote or vertical asymptote, you have to like check. If you want to calculate the horizontal asymptote, you have to take if extending to infinity, limit extending to infinity, or limit extending to minus infinity. Okay. Then you can find the horizontal asymptote. Similarly, if you want to take the vertical asymptote, you have to take y tending to infinity or y tending to minus infinity. Okay. So here you need to calculate the horizontal asymptote. So if x is tending to infinity, f of x will be tending to infinity, right? And if x is tending to minus infinity, then f of x will be tending to minus 32, right? So mathematically, from this step, you can say that the horizontal asymptote is y equals to minus 32. Okay.
Okay, yes, ma'am. Understood. Yeah.
Also, if you like want to check it graphically, then the graph, we know that the graph of the exponential function. Now here we have minus 32. So we have to like shift the graph with minus 32. Okay. So the graph will be like that. I mean, so this will be the graph where this line is minus 32. I mean, y equals to minus 32. Okay. So this is tending to 0. So this is a asymptote. I mean, asymptote means we will get some this type of picture. Okay. So graphically, y equals to minus 32 is the asymptote. And mathematically, you can just take the limit as extending to infinity or minus infinity. Okay. If you can find some finite value, then it will be the horizontal asymptote. And if you want to calculate the vertical asymptote, then you have to take y tending to infinity or minus infinity. That means your fx tending to infinity or minus infinity. Clear?
Clear, ma'am. Yeah, done, ma'am. 5.1
Ma'am,
fourth question. Conceptual doubt
one
is there.
second.
Okay.
Okay, yeah.
Yeah,
Yes, I will
ma'am.
pick all that out one by one. Yeah.
Ma'am, you were saying like vertical asymptote, right? When is that case?
Yeah.
When will that happen? Like for this function, it is horizontal asymptote. Clearly, it is horizontal. When x is equal to 0, when we calculate, we get y as minus 31. So minus 32 will be the horizontal asymptote. The point below that.
Yes. Yes, we are tending x tending to minus infinity. So 3 power x will be tending to, sorry, 2 power x will be tending to 0 and y will be tending to minus 32.
Oh, okay. So you were saying about vertical asymptote. So when is that that case? I mean, we'll have problems like
So
vertical.
suppose for this example, yeah, maybe sometime maybe you have to calculate the vertical asymptote. In that case, you have to take as your y tending to infinity. That means here fx tending to infinity. Then we can find the value of x. Okay.
Ma'am, your voice is breaking actually.
Okay. And now can you hear? Can you hear me?
Yeah, yes, ma'am, yes.
Yeah, so if you want to calculate the vertical asymptote, in that case, you just have to like y tending to infinity or y tending to minus infinity. That means if your fx tends to infinity or minus infinity, okay, then you will get some value of x. I mean, for some of x, this fx will be tending to infinity minus infinity. So then you can check. Okay.
Actually, your voice is like breaking, ma'am. Sorry to inform that.
No. Yeah,
Ma'am, could you provide one
I
example,
can
ma'am?
like Yes, sure.
Just for the vertical asymptote only, just so that we can make a difference with horizontal asymptote. Just one simple function, ma'am.
Yes, sure. Just wait. So, just for example, we can take some. Just suppose this 3 power x. Okay.
Okay.
So let us first check it graphically. So we know that the function is something like that, right?
Yes. Constraint.
So if we check graphically, then this is the horizontal asymptote, right?
Yes.
This line. That means y equals to 0. And this line is the vertical asymptote, right?
Yes.
Right? Okay. So that means if we take x tending to infinity, then we will get fx tending to infinity. So that this is not something finite. If we take x tending to minus infinity, then we will get fx tending to 0.
Yes.
Right?
Yes.
That means this is the horizontal asymptote, which is y equals to 0, right? So from the mathematically and from graphically, both we can verify it that the horizontal asymptote is 0. So same for this function, suppose we want to find the vertical asymptote, then we will x is tending to, okay, fx is tending to infinity, 3 power x is tending to infinity, right?
Yes, ma'am. Yes. If of x tends to infinity, then
Yeah. Then x will be tending to infinity. So it will imply that x is tending to infinity.
So vertical asymptote will be x tending to infinity? No.
No, because this is not something finite. No, we need some finite thing.
Yeah, finite. Yes.
If we need something finite, then we can say that this is asymptote. But if it is not finite, then there is no asymptote. We can say like that. Okay.
Okay, ma'am.
And if f is tending to, we have to check for both the minus infinity and infinity. Okay.
For the
This is clearly not possible, right?
yes, ma'am.
This is possible.
So for this 3 power x, there is no vertical asymptote.
There is no vertical asymptote.
Yes, ma'am. So I'm actually asking example, like if like 1 by 3 power x something inverse function, do we get that vertical asymptote? The graph goes from the other way.
Yeah. So this will be just the opposite. I mean, what tuition is inverse. If inverse function or this function, suppose the inverse function is exactly the like the symmetric graph with respect to this x equals to y line, right?
Yes.
So maybe the inverse function will be something like that, right? Right. So for that, again, you can check there is no horizontal asymptote, but you can find a vertical asymptote here.
Yes, ma'am.
So the horizontal asymptote, yeah. So like it will be just the opposite for the inverse function. Like if you have a vertical asymptote for the function, then you will have some horizontal asymptote for the inverse function, and it is vice versa. So it will be just the opposite for the inverse function. Okay, because property, the two functions like which are inverse of each other, they are basically symmetric with respect to the graph y equals to x. So it will have just the opposite things. Okay.
Okay, ma'am. Okay, ma'am.
Yeah.
Ma'am, in 5.1,
So
what
is it clear?
question?
I mean,
Yes, ma'am. So, but in the whole lecture, we were taught only about the horizontal asymptote, the example.
Can I say something?
Yeah, sure.
So the thing is, she's asking about the horizontal asymptote and asking about the vertical asymptote. In the exponential function, it will never happen this vertical asymptote, and vice versa. So logarithmic, you will face
Yes.
only this
Yeah.
vertical asymptote. Over there, you can feel the only vertical,
Yeah.
and here it is a horizontal. It will never interact. Yes. That is the answer for your question.
Yes,
It will
yes. Because
exponential
whenever
function doesn't have the
whenever y
yeah.
will be tending to infinity, we will never get something finite.
Okay.
for x, y tending to infinity. So for exponential function, there is no vertical asymptote for any exponential function.
Okay,
And
ma'am.
for logarithmic function, there is no horizontal asymptote. Okay, so this is general. This is something general. For any exponential function, there is only horizontal asymptote, and for any logarithmic function, there is only vertical asymptote. Okay.
Okay, ma'am. Got it. Got it. Ma'am, one common question, ma'am. Just one common question about the quiz, ma'am. Like they have published the answer key, but I couldn't find the exact key for the exam that I have written for foundation level mathematics one.
I didn't get your point. I mean, you have the answer key, but
Answer
you
key,
don't
yeah,
have
they
your
have,
answer.
they have published in the dashboard, ma'am. But if I open the drive, I couldn't find the answer key for that particular foundation level mathematics. There are many things, right? Qualifiers, BS degree. So I couldn't find that answer key for the mathematics. Do anybody face the same issue, or everyone got the answer key
Yeah,
for
you
that?
need to recollect questions, and based on that you have to pick up, because there will be two sets of questions with the minimum. So you have to just, if you can recollect some of the questions that you attended, based on that you can finalize on that goal.
No, for
Or else you have to
better,
wait.
for better,
You have to wait for your answer keys to come. Then you will get to know in yourself.
see,
Okay.
all ticket having the number, question paper code. So maybe that code you can use.
So you mean that the answer key
All,
yet to come?
Answer key released, you check the hall ticket, there will be a question pattern number like F3, Q3 kind of thing. And you can open that particular PDF, you will find your answers.
Oh,
That is
from
what
the
he's
hall
trying to
ticket.
say.
From the
You
hall
can,
ticket.
yeah, hall ticket, you can check your question pattern. What is the set do you have? Then
Okay.
open the dashboard which they given. Then open it, you will find your answers.
And the
But the
result.
answers transcripts yet to come, and answer transcript not yet come.
Okay, okay, sir. Okay, sir. Thank you. And also the results, they will take time to announce the results, or
Yeah,
I don't know
I
it.
think
idea about that, ma'am?
yeah, it will take some time. Then we will get the update. Okay.
Okay, okay, ma'am. Thank you. Thank you, sir.
Yeah. Yeah.
Ma'am, in this question, fourth question, why is option 4 wrong, ma'am? May I know?
Okay. So what is the option for? I mean, a function f from x to y is called 1, 1 if x. Okay, f of x1 not equals to f of x2 implies x1 not equals to x2. So this is clearly not the definition of the function. Now, if I mean, we can have some example, counter example for it. Just this is just a general. I mean, from this condition, we cannot say anything about 1, 1 function, no? Because if we suppose take some like fx equals to x square, for example, okay? So 4 is not equals to 3, and this is implying that 2 is not equals to 3. But this function is not 1, 1, okay? So, I mean, you can have some counter example for this option. So you can have some function for which this condition is satisfying, but the function is not 1, 1. I mean, you can have any parabola type of thing. Okay.
Ma'am, but if that is the definition of 1, 1, right, ma'am? F of x1 should
No,
not be
no,
equal
no.
to f of x2,
This is just
such
the
that x.
opposite. This is just the opposite. I mean, if x1 is not equals to x2, then it will imply f of x1 is not equals to f of x2. This is the definition. Okay.
Oh,
But if
okay,
f
okay.
of x1 is not equals to f of x2, it will not imply that. I mean, if it is implying that if x1 is not equals to x2, the function may not be any 1, 1 function. So you can take any quadratic function and you can check the quadratic function will satisfy this condition. But we know that quadratic functions are parabola, right? So it will always fail the horizontal line test. So quadratic functions are never 1, 1, right?
Okay, ma'am, understood, ma'am. Ma'am, another one is you have said that the range of composite function FOG is the subset of domain of function f of x, right?
No. Domain of composite function is equals to domain of the function g such that the range of the function G is subset of domain of the function F.
Ma'am, once could you put it on the paper once again, once, so that the words
Yeah,
are
sure.
not clear.
Okay, so basically the domain of the composite function is equals to domain of the function G such that range of the function G is subset of domain of the function F. So this is a condition. Okay.
Ma'am, then
If the
range of
G
f
is
of g is domain of, subset of range of f of x.
range of F. Yeah, range of F. Range of F compose G is subset of they can be equal. They can it can be a proper subset too. Okay, this is a subset of range of F. Okay.
Okay, ma'am. Yeah.
Yeah. Okay. Any other doubt from this things?
Madam,
Here
last
already you're saying the range, which is a subset of domain of
Yes.
F, and it should be the domain also, no? The domain which takes the G of X, that also should be intersect with this.
Yeah, domain of this is subset of domain of G actually. So we are basically just putting some condition on the domain of G. I mean, we are just restricting the domain of G to find domain of the composite function. So domain of the composite function is subset of domain of G, and range of the composite function is subset of range of F. Okay.
Okay.
Clear? Clear?
Yeah, clear.
Yeah. Okay. Any other doubt? Sorry.
the asymptotes, so it will touch the x-axis or it won't touch.
No, it will not touch. It will be something closer like that. I mean, suppose this is the asymptote, then the graph will be closer and closer, closer. When it will be tending to infinity, it will be more closer to the line, but it will never touch the line.
Okay. Okay.
Yeah. Doubt? Any other doubt? I mean, practice assignment, you have the whole practice solution available in the YouTube. But if you have doubt from the activity question, you can ask it. Otherwise, if you have any like concept related doubt, so like still, then you can ask.
Ma'am,
Any
if
other
no
doubt?
one has any doubts, could you repeat this following thing which you have written once again clearly, like
I mean,
in a elaborated way? If no one has any doubt, like if you are free, then
I mean, which one? The domain and range?
the same thing. Yeah, domain and range of this composite function. It's a bit. The first line is a bit like it's not as good as. Yeah.
Okay. Okay.
If no one has any questions, please.
Okay. So anyone, do you have any question? Okay, so we
So
can
tomorrow is a solve with us session, right?
maybe not. I mean, you have the recorded version of your solve with that session. So maybe tomorrow is no session, but you will get the recorded version. So I guess you already have the recorded version. So you can check this.
Tomorrow that is a session is a Sunday.
Yeah, there was a session. I'm not very sure about like it may not be the solve with the session. If there is a session tomorrow, then it will be the summary session for week 6, maybe. I'm
Okay.
not very sure, but up to now, what I know, maybe there is no solve with the session because you have the whole solve with the portion in the recorded version. Okay.
But it's supposed to happen right every week, and last week nothing.
Yeah,
So next
yes,
week also
but
we won't conduct for 6 weeks.
maybe solve with the session we will not conduct because we have the recorded version for solve with us.
So
So
for this week or henceforth all the weeks?
for all the weeks from now. I'm saying I'm not very confident about it, but this may be the case. I'm not very confident, but maybe there will be no solve with a session because you have the recorded version. So maybe tomorrow, if there is a session, we will directly start a week 6 summary. Otherwise, it may be like maybe there is no session tomorrow. I mean, I'm not very confident about it, but maybe.
Don't suggest this, ma'am, because solve with us gives us more. No, even though it is you will come up with more doubts when you are clearing it, and it's more interactive.
Okay.
Yeah, and I think last week, the Tuesday was the solve with test. It has become a summary. So I think it's quite ambiguous. Quite a lot of changes have happened this week, I think,
So if
because
you are
solve with test
facing
we made
more
some
doubt,
notes.
I mean, in Solve with Us, we basically solve some like 5 to 6 problem, right? So you can check it in the like recorded version. But if you have any other doubt, then we can like even in the video of the Solve with Us session, you can ask in the open session also, no? I mean, there are lots of doubt clearing session by instructor and TAs, right?
The thing
So
is, clearing doubt, it's okay. I'll come up with one-on-one doubt. When you are solving the doubt and we are giving the question to get answers, we'll come up with more ideas, and sharing ideas would be better than what you're talking about right now. So only just asking the doubts, that is different. Only I have one or two doubts, but here when I'm solving only, I'll come up with more ideas, and your inputs and your way of method is also different. What I am doing. So that was is more better for the people, that
okay,
student,
so
to understand better the
actually,
concept.
the Solvita session, all the Solvita session is actually recorded by me. So all the explanations there is also given by me. So I guess if you want to like
If
know that,
that is a sin, if that is the case, we don't want this summary session only, right? Only you take the instructor doubt clearing session. We have already recorded session of portal only has all the week wise session, right? Why we are conducting summary?
all of you don't want the summary session. I mean, I guess there are lots of
No,
students
I'm just
who need
telling.
the summary session.
No. What I am trying to say is here, because like now the summary session is supposed to happen today. It was changed to Tuesday suddenly. But people who are waiting for weekend for the summary, now there was kind of a chaos then. So now tomorrow you are saying that doubt is going to be summary session for the week 6. So what will we do for again for the next Tuesday and so on? So if the things have been changed, and that is also it is not reflecting in the calendar also. Calendar still has week 2 and week 3. So that's another confusion that's
Okay.
quite ambiguous with the calendar also, that things are not on schedule.
Mhm.
The schedule is not very clear also.
No, I just said, na, I'm not very confident. I'm not very sure. This is probably the case. So I'm not also sure about it. Maybe Vishal will like let you know surely about these things.
No. Actually, I thought today is the summary session, so I didn't know that Tuesday was the summary session.
No,
But
but in your calendar, the summary session was on Tuesday too, na?
no, it still shows that was a doubt session on Tuesday.
Oh,
It
so
still shows
doubt
as
session
doubt
for
session.
which week? I mean, week 5?
Yeah, that's what it says, because we thought
Okay.
not the doubt session, it's the problem solving session on Tuesday.
Ma'am, the
Okay,
first
so there
session
are
only it happened the summary, so we were confused.
Yeah. So
so basically, naturally, the first, I mean, for every week, the first session is a summary session. Then you have a open session, right? So this is the pattern
but
for
see, but this week we had the exam on Sunday. So
Hmm.
normally it's the case is this Wednesday, obviously we won't have the deadline for the week.
Yes.
So
Hmm.
that's one thing. The second part is that that was the problem solving session. Suddenly we didn't have a knowledge that even in the calendar, as I told you, still it says as problem solving session. It was not even changed as summary session, or there was no notification also that day is the summary session.
Okay.
And people who
So
are working, people who are actually doing other courses, they only wait for the weekend. Already there are quite a lot of queues for the people who are actually asking for weekend sessions, more sessions. But if we actually change that main sessions to in the middle of the week, and if things are going to change without any prior knowledge, then we won't be able to keep track of it, how things happen. Rather, for example, on the day of Diwali, we had a session, but for from some reasons, the session got cancelled, which we got to know only the following day. I came online and I was waiting for almost 10 minutes or something, and even some people joined and they also left. But we were not informed about the cancellation of the session also on the day. The problem is like we come with a certain schedule, and most of us, I think many people are doing parallel course or parallel working in this thing, and we actually go with
I
the
can
schedule.
understand.
But because the TA session that you do that's happening on the weekdays, that's really one out of, I think, if you're talking about the numbers that have been, the assignments numbers that I see is almost 5,000 or something, and the TA session hardly some 10 people or 15 people come for the TA session, as you could see that also.
Yeah.
Even today also we could see hardly 18 people here, but the number of submissions 5,000 plus. So, but one thing is like if you can actually stick to, I see only in Max we have this issue. Whereas in Start and this thing, there is a proper schedule happening there. But whereas in Math, like we see a last minute cancellation of the TA session or this change of summary to this thing. So, because last week itself I told about this, that the session was cancelled in the last minute, and they said, okay, we will take care in the future. Again on Diwali it happened, the same thing. And now today the summary session
Yeah,
already is over on Tuesday.
okay.
And tomorrow
I
we
was not aware about that, but yeah, I will talk to my team about
yeah
it.
even like I think one of the cases, I think it was not you, I think it was Samiksha was there on the day, and even somebody was actually asking for more doubts in the summary session, and we actually requested not to bother during the summary session, saying that the doubt clearing session and this thing will be there separately. But things if we change, then automatically we won't be able to, and we see it as only one opportunity to go through this thing, and where we can actually learn from you in the summary session to do it. That's one thing. That's the reason I also asked you whether the summary is already over. So I think in the next week, if
Yeah.
you, yeah, next week, tomorrow you are going to conduct. Again, the following week, again there will be a schedule change and so on. Again, so it will be kind of, it's going to be a kind of next 4 weeks we will have a kind of ambiguous schedule that's going to happen.
No, 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 no. See, I will talk to my team. I just said you that I'm not very confident
Happen if
about
I'm
it. So there may be a session, but there is a chance that there will be no solve with the session. But if this is the case, I will try to like confirm it before, at least before some hours of your class. I will definitely try to confirm. Yeah.
Yeah, because we need to actually, I mean, for example,
Yeah,
on
I
the
can
day,
understand.
yeah, I
Mhm.
need to leave a meeting halfway through a meeting, and I was there only to see that things didn't happen on the day. So that's
Yeah,
another.
this is a really ambiguous situation. I can understand, but yeah, I will definitely try to like make sure, like
Yeah,
so that
but I
all of
have
you
very
can get the
yeah,
information.
and but I have very strong request in terms of the calendar, because in the calendar it's not, even the weeks are not properly updated, sessions are not clearly defined. So I request you to at least the calendar be strictly maintained, so that we will get to know how things are going to happen in the week. That will be better.
Mm-hmm.
Even if the calendar is not reflecting properly, then the ambiguity will continue, like for everyone.
Yeah, this is true. So I will definitely try to rectify it. I will talk to my team about it. And but roughly what I can say that your Tuesday you have three sessions, three instructor session, Tuesday, Saturday, and Sunday, right? So you have the summary session on Tuesday, and this is something like general. I mean, you
No,
used
no.
to have the summary session on
Tuesday,
Tuesday, no? Yeah.
no, no. I mean,
I
as per the calendar, Tuesday it says problem solving, Saturday it says summary, and Sunday it says doubt clearing session.
Okay. Maybe, yeah, maybe there was some mistake. I will check it. Then I will, yeah, I
I
will try
think
to
that
rectify.
because like normally we have the deadline on Wednesday, so the Tuesday there is no point in having a. So in the summary session, if you keep it on Saturday, that will be more ideal, or on Sunday.
Okay. So, yeah, I will talk to my team about your. So you
I'm
want summary
also
session on the weekend, right? I mean, you
Yeah,
want the
because
summary
that's more
session.
ideal. Yeah, that will be more ideal because Tuesday, like we will have the kind of if we do a problem solving, Wednesday we will have the thing, and again Saturday and Sunday, if you have the core thing on Saturday and Sunday, that will be more ideal for everyone, I think.
So, are like, if is everyone like has the same type of say?
Ma'am, everyone are not present right now.
I mean, who are
Yeah,
present?
majority is
ma'am,
same.
majority,
Yes,
Yes,
ma'am.
I
Like
ma'am.
want to know for
requesting
majority.
for open session also, ma'am. Open session, like it
Don't
is
close
taking
any
time.
session.
It is taking time to upload the live session. We are almost completing the chapter, so it will be useful if we get the recordings a little before. Like if not on the
Okay,
same
for
day
the
or
TA
one day.
sessions, right? I mean, for the
Yeah,
instructor session, you have the live streaming, but you need
yeah,
the
yeah.
recording for the TA session.
TA
TA
session,
session.
Yeah.
yes, ma'am.
Because
Yes,
Yeah,
yes.
we can refer that for problem solving also. Some problems will be solved in that, so we can refer that.
yeah,
And
Arav,
ma'am,
I think
summary
till
session.
yesterday it is there. Arav, till yesterday it's been uploaded. It's everything is there. Only for today.
Sorry, actually, my name is Tina. Name is not updated.
Okay, fine. Hi, Tina. So the thing is like till yesterday it's upload. The things are uploaded. Only for today it's not there.
For the TA session, you say?
Yes, yes, TS session. You go, Joe, refresh the link. You will see it's been updated now.
Oh, because just now I tried. I was
Oh,
asked
no,
to
you can check
request for
it
the
once.
access.
I mean,
Okay,
No,
ma'am.
see, today's session in my calendar is showing summary only. So is there any
No,
change
in the
okay.
actually?
afternoon, in the
No,
afternoon
no,
we have
no.
a TS
This
session.
is the open session. So maybe there is some misleading information in the calendar. I will check the calendar once, then I will like try to rectify this misleading things.
Okay.
So is it the case for this week only, or it's for every week? I
No,
mean,
this
just
It's
this
for
for this
upcoming
week.
week also.
upcoming week also. We see week 2, week 3, and
Week
things
1.
are
Okay.
week 1.
Ma'am,
Okay, okay,
please
okay.
take
I
summary
will try
session
to
on
upload the
weekends.
calendar. Okay, so majority of you want the summary session on weekend, right? So this is
Saturday
the
and
Yes,
Sunday.
request
ma'am.
from you. Okay,
Saturday
okay,
and
Yes,
I
Sunday
will
ma'am.
ideal
come.
for them.
Yes,
Because
okay.
these
Then
sessions are very useful, ma'am. Even for preparing for quiz, we were finding it very useful. Like
definitely you have to like clarify all the
that.
concepts.
Yes, ma'am. That is for that too. For mathematics, it's very very useful, ma'am. Because everyone will have different point of perspective in asking doubts, and also we will be thinking in
Yeah,
different ways. Yeah. So it's really,
definitely.
really
Yeah, I agree too.
See, today afternoon TA session, what they told actually, the instructors, the recording maybe the uploading, it's taking the 24 hours time. So if you want urgent, what they told, at the same Excel sheet, right hand side have the previous time links are there. So maybe you can refer that also. That is the information they provided today. Maybe somebody is having that information, maybe it will be useful.
Yeah,
Arun,
actually, they were saying that links were available in the Excel sheet, but most of them did not. They don't have the access to that Excel sheet. Like they did not send it through email or something. I
Okay.
got it through Discourse. From Discourse, I was searching like for open
Yes,
session.
yes. Yeah, yes.
The
This
Excel was
I
shared in the
agree.
Discourse.
Yeah,
But
yeah.
you can access them, na? I mean, from discourse at least.
No, no, it's not open for everyone. So every
Yes,
time we
ma'am.
need to give the request. So that is one of the
Even
problem.
many of
Okay,
them
okay.
not aware also, ma'am. Many of them not aware.
no, Tina. The case is that this Excel sheet is created by the TAs, and they are maintaining for every semester. And this is exclusively it has been created because like people who don't have access to Discourse, they can also go with this thing. They can easily access through this links. So if they just post it, because last semester there are a lot of things that are only posted in Google groups or the thing which many people didn't have an access. So in the math, the instructors create a whole Google sheet every semester, every term, and they're maintaining it. And this time I see even they actually have the archive also being maintained, the previous thing also, previous semester also. So that's the reason it has been created. It has been exclusively
Okay.
created by the TAs and maintained by the TAs.
Okay,
Ma'am, could you
I
continue
will
with
talk.
some class for 5 minutes
Yes.
at least?
Yeah, because if I just had all the problem regarding the system, so I will talk to my team about the problem. Let's just continue about the things, okay? I mean the concept, okay?
Before you start, I just have a basic doubt. So the summary session, it's always Samiksha takes and the doubt session you take, or anybody will take any session?
No. This is not the case. Anybody can take anything. Like yeah.
Okay. Because I thought like normally only she takes the summary and you take the
No,
doubt.
no. This is not the case. Actually, last day I was going to take the summary session, but because of some problem, I couldn't take it. So instead of me, Samiksha had to take the summary session.
There is
So
also one more
this is not the
instructor,
case.
right? One more instructor is there, right?
Yes.
Deepak
Vishal.
Gupta.
So you had a class of Vishal also, right?
Vishal or some Gupta or somebody was there, right?
No. Samiksha, me and Vishal. We are the only instructor for
No,
this.
today one person, new person actually.
That is for the TA.
Yeah, today is one person, new person, not Vishal.
No, that's for TA. It's not an instructor.
No,
That's for TA.
TA sessions are different and instructor sessions are different. So
Oh,
for
Vishal.
this Math 1 course, you only have 3 instructor, me, Samiksha, and Vishal. Okay.
Okay. Thank you.
Yeah.
Thanks for the time. Sorry to break you.
Yeah. Let us now move with the concepts. So, yeah, you were just asking me to elaborate this domain and range of a composite
Yes,
function
ma'am.
in detail. Yeah.
Yes, ma'am.
So, what is the definition of the composite function? I mean, f compose g of x means f of g of x, right? This is the definition,
Yes, ma'am.
right?
Yes, ma'am.
Yeah. So basically, we need first to be defined this portion, right? I mean, this portion should be defined first, and that means g of x, right?
Yes,
Right?
ma'am.
If this portion is defined, that means x is belongs to d of g, right?
Yes, ma'am.
Otherwise, it will not be defined, right? Now, once this portion, I mean g of x is defined, now we need to define this whole thing, this whole term, right? F of g of x. Okay. Suppose y equals to g of x. Okay. This is a defined number. So now we need f of y to be defined. That means this y should be in the domain of f similarly, right? Otherwise,
Yes,
it will
ma'am.
not be defined. Okay. So y means again g of x, right? That means g of x should be domain of x, right?
Yes,
Right?
ma'am.
So from here we can imply that range of G will be subset of domain of F. Is it clear now?
Yes, ma'am. Yes, ma'am.
So that is why I'm saying this line, that domain of this composite function will be equals to domain of G such that the range of G is subset of domain of F. Because we need to define the function. That is what we want, these two conditions. And these two conditions are coming for this reason. Now is it clear? The conditions specifically. Why are
Ma'am,
we taking
ma'am,
this
another
range of G subset of
at the top you have written it is a subset of or equal to domain of G, right? What is that again?
this one?
Yeah.
This line?
Yes, ma'am. Yeah, in that line at the end, right side end, you have written it is a subset of
Yeah. So
or equal
this,
to.
I mean, that means domain of F, the composition function is subset of domain of G. Okay. So if we
Okay.
want to
Yes, ma'am.
suppose if there is some x in domain of the composite function, then we first need to define g of x, right? So it will imply this x is belongs to d of g, right? Right?
Yes, ma'am. Yes, ma'am.
So from this we can imply this line, domain of the composite function will be subset of domain of g. Okay.
Ma'am, is this for inverse function or the composite function, this rule?
Any composite function, any composite function.
Okay.
Yeah, any composite function. So the
Inverse is
domain,
different.
yeah, inverse is different. This is for any composite function. Okay. And the range of f of g, that means the functional value of f of y, right? So this is clearly subset of range of F, right?
Yes, ma'am. Understood. Understood the second point. Yeah. Yeah, done.
This,
Understood, ma'am. Understood.
and what about the first point? The first point is clear.
Yes,
Domain
ma'am.
of F
First
of
point is
G,
clear.
subset of domain of G, and we need that range of G should be subset of domain of F. Like we need to restrict the domain of G in such a way such that range of G becomes subset of domain of F. Okay, because we need to define the function, right? So
Yes,
is
ma'am.
it
Understood.
clear now?
Fully clear. Yes, ma'am.
Okay, so whenever you have a function and you are asked to calculate the range and domain of the function, you always need to follow this 3 step. You have to first calculate the domain, that means the point at which point the function has no disturbance, roughly speaking. Okay, then you have to check the function, the behavior of the function at the boundary point of the domain. Okay, then we will get some value. According to the value, we have to calculate the, you have to conclude about the range of the function. Okay, so you may have this type of question in your exam too. So you may have to calculate the range and domain of some function. So always you have to do this type of thing. And once you have range and domain to function, then you can calculate the range and domain of the composite function too. Okay.
Yes, ma'am. Yes, ma'am. Got it.
Yeah. So this is the same way. Like if you want to calculate the domain for the composite function, you just have to restrict the domain of the function G in such a way such that range of the function B become domain of the function F. Okay, so you have to follow this 2 to 3 step, and these are enough. If you just practice this type of thing, you have lots of question in which they asked you to calculate the range and domain for the function. So just practice all the question in this using this 2 or 3 step. Okay, so you will become more comfortable in this way, and it will be no problem then. Okay.
Yes, ma'am. Yeah, we have to did in today's session also. Yeah, understood.
Yeah. Okay, so I guess all of you are like now at least comfortable than earlier with the this type of thing, right? Range, domain, asymptote, composite function, and all.
Yes, ma'am.
Okay. So do you have any other doubt?
Ma'am, could you solve one activity question, ma'am, like 5.9, fourth one? The answer is the second option, but it is asking for incorrect option. 5.9, fourth question.
Okay. This one.
Yes, ma'am. So the answer
Where
was
to find?
incorrect
Check
statement.
down.
Fourth one.
Fourth one. Okay. Okay. So what is the problem here? What is the problem here?
So the second option is the correct one, but I didn't get it actually when I was solving. We have to prove that f of x is equal to inverse of.
If this happen, then we know that f compose f of x equals to g inverse. That means g
How do we
compose
approach
g
that?
inverse. G compose g inverse equals to g inverse compose g equals to identity, right? That we know. This is the condition, right? That means G compose F equals to F compose G equals to identity.
Yes, ma'am.
Now you will just have to check whether it is satisfying or not. Now can we solve it?
With the second one, G compose F is
Okay.
equals.
So you just let us check it. What is G compose F? So G is our this 11 minus 1 by F. So and what is our F? This is this. Then we will get this, right? So then 11 minus 1 over x minus 11, right? No, sorry, 1 over x minus 11, right? Because we have 1 over x, we have to put this thing instead of x, right? So we will get 11 minus x plus 11, right? Right? So this is clearly not equals to x.
Okay.
So this is incorrect, right? Hence this is the correct answer, because we need to check, like, collect the incorrect answers, options, right?
We have to prove that it is equals to x. That's
Yes.
what you're saying.
Identity, yeah. Identity function means if we take x here, we will get identity of x, which is equals to x.
Okay. So if we get x there, so then the option will be correct. Since we are not getting.
Yes. So f compose f inverse of x equals to f inverse compose f of x is equals to x for all x. So if you are getting this, like f compose g equals g compose f equals to x, then this is correct. Otherwise, this is incorrect. So we cannot get x if we do the composition. So clearly this is incorrect. Hence, this is the correct answer. Okay.
Okay.
Sorry. Okay. So it's clear?
Yes, ma'am.
Okay. Okay. So any other doubt? Any other doubt? If you have doubt, you can ask. Otherwise, we can close this session too. So if you don't have doubt, you can leave. Otherwise, you can ask.
For me, I had to go through the summary session, so sorry for that. Fine. Go through that.
Okay, so I want to tell you that like the session, I mean the week 5 portion was basically about this type of things. I mean the composition of function, the exponential function and all. Okay, so I just covered the composition of function, and the exponential function thing is, this is just a power x in this format where x is not equals to 1, and you just have some graph of the function, just this type of thing. Okay, so I just explained some theory which covers some portion from the week 5 summary portion too. So you can go through this recorded version of the summary sessions. If you have still doubt, then you can ask in the next session too. Okay, in my next session I will assure you, I will pick your doubts if you have doubt related to this week. Okay.
Okay. And when is your next session? You'll be coming on tomorrow?
I'm not sure, but probably tomorrow.
Tomorrow. Okay, fine. Then it will be. Okay, in the meantime, I'll go through the summary.
If it is not the case, then we will update in the calendar. And if it is the case, then you just like go through the summary session. Then if you face some doubt, you can ask me. I will clear your doubts. Okay.
Okay, thank you so much.
Yeah.
So from next week, it is like from week 6, ma'am.
Yeah.
Okay. That is going to happen from Monday, I mean the Tuesday class?
Probably Tuesday. It can be Sunday also. Like I'm not so sure about it, but I will definitely try to update the thing in the calendar so that you can check it before your class, at least before some hours. Okay.
Okay.
Yeah.
Okay, ma'am. Thank you for the session.
Yeah. Welcome.
Because like
Okay.
other thing is also that because when you say the Tuesday is the, can you hear me?
Yeah, sure. Yeah. You can tell.
So for example, in the normal schedule that you normally we have is every Wednesday is our assignment deadline. So unless we have the summary session, at least I mean if Wednesday is let's say that coming Wednesday is the deadline. If you have the summary on Thursday, then it is useful. But if we have the summary on Tuesday, hardly the next day is the deadline for us.
Okay, I will talk to my team so that we can ship the summary session on the weekend. So
Weekend, that's
I
I
think
mean Saturday is
majority of
ideal day, I think.
Yeah,
Saturday
so
is very
majority of you want it on the weekend. So I will talk to my team about this. Okay, we will try to shift it on the weekend.
Yeah, because even though I mean, for example, the other course also they suggested that we can have two sessions on Wednesday, but Wednesday is a very peak day for
But
everyone with the deadline and
Wednesday
so on.
you don't have any session, math one session, na? I mean instructor session you don't have.
Yeah,
You
I mean that
only
is also
have
kind
on
of this.
Tuesday, Saturday, and Sunday.
But this Wednesday we have a session on TA session on there on
Okay,
computer.
TA sessions are were there maybe, but there was an instructor session.
There is also an open session on Wednesday from 4 to 6.
Okay, okay.
That is also by TS. I don't know. Oh, sorry. Yeah, that's open session
Yeah,
by TS, not for the
it
instructor.
was TS. Yeah, it was by TS.
Yeah. So I would. I mean, for me, I think most of us are happy. We would appreciate if it's happening on Saturday is very ideal for us. Even though from
Okay,
Thursday,
okay.
Friday, Saturday, again, even after the deadline, people again who are working again, either it should happen only in the late in the night or it happen on Thursday, same time, Thursday to Friday, same time, or ideally on the Saturday, that will be more ideal for everyone else.
Okay, I will definitely talk to my team about this. So we will definitely try to ship the summary session on weekend.
And kindly ask your team to change the Google Calendar, update the Google Calendar.
Yes.
Currently, it's
I
very
will
confusing.
definitely look after that. Yeah.
Thank you so much. Thanks a lot.
Welcome.
Good night.
Okay, so if you don't have any doubt, you can leave, or else you can ask. Okay, so I guess you don't have any doubt. So maybe we can end this session. So okay, so a good night for all of you.
Thank you.
Yeah, welcome.